Hey kids, here we are at Objective 24. We have done a similar lesson to this, but today we are going to choose appropriate units of measurement. That's the focus for a number that's in scientific notation. So we are going to make approximations or estimations, and previously we kept the same unit of measure down this side and had different exponents on our base 10. This time we're going to have the same value in different labels in our approximations. Both skills are important, are valuable, but we split them apart so that we can focus on the subtle differences between them. So rather than doing lengthy notes on these, we're just going to jump in with some examples. I think the most important skill in this is for you to find points of reference for these different units of measure. So let's think of a normal school bus. How long is a school bus? And all of these start with 4.5 times 10 to the first. Well, let's work backwards. 10 to the first is 10, and 4.5 times 10 is 45. So we're dealing with 45 inches, feet, meters, or miles. Okay, and I will explain some of these, even though it seems silly to you. Not everybody knows all of these, so I'll give you a little reference here. So an inch is typically about the length of one digit in your finger. There are 12 inches in a foot, so 45 inches would be not quite 4 feet tall. And speaking of feet, foot is, if you can think about the tiles on our floors at school, those are about 1 foot in diameter, or not diameter, I'm sorry, 1 foot by 1 foot in area, or 1 square foot. Also, a person, a grown-up, tends to be around 5.5 feet tall. Okay, so this says 45 feet, so that would be about 9 people standing head to foot on the parking lot. Would that be the right amount? Obviously, less than 4 feet would not be acceptable for the length of a school bus. The next one we have here is 45 meters. A meter, if you think of a football field, and these are the yard lines. There should be 10 if I was drawing it correctly. The track that goes around the football field, that's not perfect, is 400 meters. And the straightaway is about 100 meters. And so 45 meters would be about half the straightaway of a football field. Or many of our students at our school are familiar with the 50-meter dash that you have to do at least twice a year. So that's kind of a long way and not really feasible for a school bus. And then 45 miles. Obviously, that's an incorrect response. 45 miles would maybe be the distance you would travel on a school bus, not the length of a school bus. So the way that these are provided to you, typically 2 of them are meant to be ridiculous, and then you'd have to use a little bit more discernment for the last 2 options. So we know that it's not going to be less than 4 feet, and we know that it's not going to be 45 miles. So would a school bus be closer to, say, half the straightaway of the track around the football field, or would it be, or about the length of 9 to 10 people laying head to foot? Did you say B? That is correct. The school bus is 45 feet long. Okay, so how tall is LeBron James? And some criticism we get is, why do I care? Who knows this? I can get through life just fine without knowing the exact height of these things, and I totally get that. The skill that I'm trying to teach you is how to make a smart choice, knowing about scientific notation and the value of each of these labels. Don't worry, I've made it just fine in life 30 some odd years not knowing how tall LeBron James is until I looked it up for this math question here. Okay, so we have 8.0 times 10 to the first again. Remember, 10 to the first is 10. 10 times 8 is 80. So our comparison will be 80 inches, 80 feet, 80 meters, and 80 miles. Well, we know right away that one's ridiculous, right? 80 miles? That's silly. Well, let's work our way backwards. 80 meters, if we use this again, that again is almost half the length of a football field. Absolutely not. 80 feet. Well, he might be tall, but this is like Jolly Green Giant tall. That's like a 8-story building. That's not at all an option. So this one worked out a little bit easier for us. LeBron James is 80 inches tall, which is, I think, 6 foot 8. So that would be the size of a tall human. Okay. Here is a time question rather than a length or distance. And it's also a real situation. This is Joey Chestnut. He is the champion of 11 consecutive hot dog eating contests, and he's still going. As of 2019, he won again. I don't recommend watching those competitions unless you have a very strong stomach. So, how long does it take Joey to eat a hot dog? Now, he eats hot dogs for a solid hour. That's the length of the competition. Okay. So we have 8.57 times 10 to the negative first seconds, minutes, hours, and days. So this is a little bit difficult. Now remember, when we had times 10 to the first power, we could move our decimal one place to the right to get the correct value. Well, if it's -1, we can move the decimal 1 to the left. So 8.57 becomes 0.857. This also makes sense because 10 to the negative first is the same as 1 over 10 to the first, or 1 over 10. So that would mean 1/10 of 8.57. So 1/10 of 8.57 would be 0.57. 0.857, sorry. Okay. So if this were a percentage, this would be like about 85% of second, minute, hours, days. So how long does it take him to eat a hot dog? Well, would it be almost a whole second, 85% of a second? That'd be really, really fast. I'm going to say probably not, unless he's really impressive. How about almost a minute, like 85% of a minute? That one's a little bit closer. That'd be like 45 seconds or so, maybe a little bit more. I'm going to circle that for a maybe. How about, let's see, about 85% of an hour? Well, that's an impressive. I can do that. Or a day? No, not at all. So now I need to choose, is it closer to be like 45-ish seconds or not even a second? I'm going to make the choice of B, which is correct. Joey Chestnut, if you're interested, eats about 70 hot dogs with the bun each hour that he competes. So there's a little food for thought. Ha 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 ha. If you'll forgive me for my joke. Okay, let's measure something even tinier. The diameter, or the distance across, typically something round, of a drop of water. So we have here again a negative exponent, and again they're all going to be the same. So if a -1 moves the decimal 1 place to the left, a -2 moves the decimal 2 places to the left. So I did have 1.0. I'm going to move back 1, 2 place values. So I have 100th. 100th of an inch, a foot, a meter, and a mile. Okay. A drop of water is pretty small, but we can still see one, right? Okay. So 100th of an inch. So if I take this distance and then I divide it into 100, that would be, let's see, 100th would be, that would be half of an inch. That would be a quarter of an inch. Like 100th of an inch is just too small to even to be an option. 100th of a foot. Again, if you think of those tiles that we have at school, That would be something to consider. 100th of a meter. A meter is a bit longer than a foot. And 100th of a meter, well, that's not at all impressive. Okay. All right. Here's something else that might help. 100th of a meter. Oops. While I'm trying to judge between both of these, one thing to consider is another value that we might be familiar with. I'm looking for 100th of a meter. So 100 of these things go into a meter. Do you know what that would be called? A centimeter. There are 100 centimeters in a meter. So if I have 100th of a meter, that would be a centimeter. Does it seem logical that a drop of water would be about a centimeter in diameter? Yeah. A centimeter is... I'm actually going to stop there. Sorry, kids. I was distracted a couple times when I was explaining that question. There's a typo on this page. These are supposed to be 3s. Okay. As I was talking, I was just thinking, this is not working out. So this would be 0.001, so a 1/10 of a centimeter. All right. And I was just thinking, a centimeter is about the length or the distance across your pinky fingernail. So a 1/10 of that would be the diameter of just a drop of water. Okay. Sorry, that was a little bit shaky there. I apologize. All right. The lifespan of a cat. All right, so this is a standard cat. It doesn't have any amazing skills for longevity or anything. It's not a kitten, it's a regular cat. All right, so we have 4.7304 times 10 to the 8th. Well, that's kind of difficult, right? I'm going to move my decimal 8 places to the right. So it was 4.7304, so I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 473,000 things, right? Okay. Is she 473,000 seconds, days, years, or decades? Well, definitely not years or decades. We all know what a year is, right? And a decade is 10 times more than that. And then we have to choose between these two. I have a very difficult time wrapping my head around 473,000 of anything. So I may need to use some calculator work to figure that out. Let's see. If I had this many days, I would need to break that down into years. That's typically how we measure age, so that I can kind of understand that a little bit more. So I would need to determine how many years this many days is. So I can use my calculator to do that. I don't have one in front of me, but I have Alexa here. Alexa, what is 473,000 divided by 365?
473,000 divided by 365 is 1,295.8904.
Okay. So cats have 9 lives, but they're not going to be 1,295 years old. So this will be my final solution. Notice I didn't divide all of the specific numbers. I'm just looking for a ballpark. And why did I divide it by 365? Because there's 365 days in a year. So sometimes you actually need to pick up a calculator or do some little jotting in the margins to figure out your solution. Okay, so your homework is just like your notes. It's an opportunity for you to practice, use reasoning skills. Again, there should be 2 obvious no answers and then 2 for you to kind of muddle through and kind of struggle along with, and I'm always happy to help too if you need any help with that. So make sure you're on the homework side and you have 5 questions. The depth of a swimming pool, this is like a normal swimming pool, not a kiddie pool. The height of a regular kitchen table. the age of your teacher. I know we look really old and tired, but I am somewhere between 20 and 60 years old. There you go. Gave you a clue. The length of a grasshopper, those are those big green bugs that you see hopping around, usually near the fields. And the width of a regular pencil erasers that you would have at the end of your pencil. Not the big white pink erasers, but the ones at the end of your pencil. Okay. They, again, have the same base number for each one. You're just choosing among the different lengths. So good luck with that. And please, of course, if you have any questions, you can email me. And I am happy to help. Or, of course, you can come see me in class. And I didn't do my disclaimer in the beginning, and I should have, because I kind of had a little rough patch in the middle there. These videos aren't perfect. I do my best. Another teacher may or probably would do this a little bit different. This is just the highlights from class. Our lesson took a lot longer than 15 minutes. This is just meant to help kids from home, get you started, refresh you, so that you can get your work done, so you can practice this. All right, thanks, guys. See you in class. Bye.